Geometry is the language of space. Everything you see around you, your phone, your room, the planet you're standing on, is just a bunch of shapes combined. Now let's get ourselves out of the atmosphere for a second. If you've ever been to space, well, you'd know the Earth looks like this. Oh, sorry, wrong picture. It looks like this. That, my friend, is a perfect blue sphere. And that sphere, it's just one example of geometry in action. But here's the crazy part. There are shapes you already know: squares, triangles, circles. Those are two-dimensional, flat. Now take some of those shapes and stretch them. Fuse them together and suddenly you get three-dimensional shapes: cubes, cylinders, spheres. Now combine those and you get everything: buildings, cars, your coffee mug, even you. You are walking geometry. Now let's say you wanted to measure something, like how big the surface of this thing is. That's called area. To understand it, imagine peeling the surface off and laying it flat. Now you can measure it. Base times height. Boom. Area is measured in square units. Most shapes follow that simple idea. Base times height, a rectangle. Base times height, a triangle. Same idea, just divided by 2. Almost all of them. Because of course, the circle had to be different. For a circle, you use pi times the radius squared. Classic circle behavior. Now what if instead of the surface, you wanted to know how much you could stuff inside something? Like, how much cash could fit inside a vault? Now we're talking about volume. Volume tells you how much space is inside a shape. For most 3D shapes, it's simple. Take the area of the base and multiply it by the height. A box, base times height. A cylinder, still base times height, just with a circular base. And again, except, you guessed it, the sphere. The sphere said, nope, which now times pi by the radius squared because spheres like attention. But here's where geometry gets even crazier. What we just talked about, that's basic geometry. There's a whole other world, differential geometry, where we study curves and smooth surfaces. Non-Euclidean geometry, where parallel lines can actually meet. Yes, meet. And fractal geometry, the math of nature. Infinite patterns, inside trees, snowflakes, nautilus shells. Geometry isn't just shapes in a textbook, it's the structure of reality. So next time you see a circle, or a cube, or even your reflection in the mirror, remember, you're not just looking at objects, you're looking at geometry. And honestly, that's pretty beautiful. To truly understand the angles and hidden connections between these shapes, we need a new set of tools. So keep that geometry in mind because we'll see trigonometry in the next video. Subscribe to stay tuned for the next lesson.